All right, so looking at the second part of the sample test, picking up with number 23, they wanted us to tell if these were even, odd, or neither. So if they give me a equation, the way that I'm going to test that is I'm going to put a negative x in the place of x. So my equation was x to the fourth minus x squared, so let's put negative x in for x and negative x in for x. So a negative to the fourth power is going to be positive, and then x to the fourth. And then a negative squared is positive, so this would be positive x squared, and then it was being subtracted, so subtracting a positive x squared. So if you'll notice, you got the exact same thing you started with, so when you get the exact same thing, it's even. All right, then we're going to try this next one, put a negative x in the place of x, so negative x in for x, negative x in for x. And so negative x to the fifth is going to be negative. So we're going to have a negative 2x to the fifth. And then negative x cubed is also going to be negative. So minus a negative would be plus. So that is not the same thing I started with. I want to check and see if it's the opposite of what I started with by factoring out a negative. So if I factor a negative 1 out of this, then that's going to be a negative 1 times 2x to the fifth times a negative x cubed. So you'll notice inside the parentheses, that is the exact same thing I started with. So that is the opposite of the exact same thing I started with. So if it's the opposite of what I started with, that is odd. All right, then for this next one, I'm going to put a negative x in for x. So that'd be negative x squared plus 3 times negative x. So the negative squared is positive, so that'd be positive x squared, and then 3 times negative x is negative 3x. So that is not the same thing as what I started with, and if I factored a negative out of this, I'd get negative x squared plus 3x. That is not the opposite of what I started with, so that's what a neither looks like. All right, then for D, E, and F, they gave us a graph and we were trying to look at the graph and tell if it was even, odd, neither. All right, so for D, if you take your picture and you turn it upside down, it is the exact same picture upside down as it is right side up. So that means it's symmetric to the origin. It's an odd function. For the second graph, for E, if you folded your paper on the y-axis, that graph would fold right on top of itself. So that means it's symmetric to the y-axis. That means it's even. All right, and then for F, neither one of those things are true. If you turn it upside down, look at the y-intercept. You'll notice that one's positive and one's negative, right? So it's not the same thing upside down as it is right side up, and you can't fold it on the y-axis and it fold on top of itself. So that's what a neither would look like. Then they ask us to work with some graphs. So let's look at number 24. We've got f of x is equal to 2 times x plus 4. So our toolkit function there is the square root of x. So our normal beginning function, square root of x right there, we need to know what that toolkit base function looks like. All right, then this positive 4 right here, any value subtracted from x is a horizontal shift. That's stuck to the x. It can't be moved to the other side and grouped with the y. So that's a horizontal shift of negative 4. All right, then this 2 out in front, anytime you have a number being multiplied times your function, that's going to be a stretch or shrink. So if it's larger than 1, it's a stretch. If it's between 0 and 1, it's a shrink. So ours is going to be a stretch. All right, so remember the order that we want to follow. You can use your stretch at the beginning or at the end, whichever you like better, but we do have to horizontally shift and then reflect and then vertically shift. All right, so for this one, here's our y equals the square root of x. All right, then I have a horizontal shift of negative 4, so I'm going to back that up 4, and there's that exact same thing. And then stretch by a factor of 2, I just want it to go twice as high. So this one was going through 2, and you can see this one's going through 4. It's like twice as high. All right, so let's look at this next one. So for this next one, we've got negative absolute value of x plus 2. So our base function or our toolkit function is going to be absolute value of x. So here's that base or that toolkit function that we're starting with. All right, then you can see that with this 2, You could subtract it over to the other side and group it with the y, so it's not stuck to the x, so that's going to be a vertical shift of 2. Any value subtracted from y is a vertical shift, so vertical shift of 2. And then the negative out in front of the function here is going to cause a reflection in the x-axis. That negative is not in front of x plugged into the function, it's out in front of the function. So reflection in x. All right, so remember that you do have to reflect before you vertically shift. So I'm going to take this graph that we had right here, and then I'm going to reflect it right here, and then I'm going to vertically shift it up 2, and so there's my final graph. All right, for the next one, we've got x minus 1 squared plus 3. So our toolkit function is y equals x squared. All right, so you can see that this one's being subtracted from x. It's stuck to the x. It can't be moved to the other side, so that's a horizontal shift. This 3 can be moved to the other side. That'd be y minus 3. So what's being subtracted from y is a positive 3. That's a vertical shift of a positive 3. So I'm going to start right here with my toolkit function, my base function y equals x squared. And then I can horizontally shift 1 and vertically shift 3. And you could do both of those at the same time if you want to, or you could do it in 2 separate steps. So again, all of those base graphs were our toolkit functions that we should know. All right, then for 25, they gave us the graph and they asked us to come up with the equation. All right, so our base function is our parabola, y equals x squared. That's our toolkit function. And so if you look at your graph, you can see that normal parabola has been horizontally shifted to the right, a positive 3, and vertically shifted up 1, so a positive 1. So to write our equation, any value subtracted from x is a horizontal shift, so that'd be a horizontal shift of positive 3. Any value subtracted from y is a vertical shift, so positive 1 is being subtracted from y. Remember that you have to put the 3 inside those parentheses and then put the square on the outside in order to stick it with the x so it can't be moved to the other side with the y. All right, then for B, again, we had that same starting quadratic parabola, but for this one, it horizontally shifted to the right 2, so positive 2, and it reflected in the x-axis because it was opening up and now it's opening down. So any value subtracted from x is a horizontal shift, again, inside the parentheses stuck to the 2, so it can't be moved to the other side. And then a negative out in front of the entire function will cause a reflection in the x-axis. All right, then for 26, we worked with solving some absolute value equalities and inequalities. So when you have an absolute value, remember you have to get it alone on one side by itself. So let's subtract the 6 from both sides, and that will give us absolute value of x minus 2 is equal to 2. And then we're going to take what's inside our absolute value and set it equal to a positive and a negative of what's on the other side. So what's inside the absolute value equal to a positive, and what's inside the absolute value equal to a negative of that 2 that was on the other side. So to solve this, add 2 to both sides and we'll get 4, and then here add 2 to both sides and we'll get 0. All right, then for B, we had an absolute value inequality. So remember, this is the one you want to look at and see, does that look like the C or the D? So that's the one, if we put a little line right there, it looks like a D. That's our disjunction, that's our OR statement. All right, so we're going to have x minus 2 is greater than or equal to 8. And then remember, copy the same sign on the other side and copy the opposite number. So negative 8 is greater than or equal to x minus 2. All right, so now to solve these, let's add 2 to both sides. So negative 6 is greater than or equal to x. And then here add 2 to both sides. X is greater than or equal to 10. And then here's our interval notation for that as well, continuing to practice with that. All right, then for 27, they ask us to take an absolute value function and perform several transformations on it. Okay, so let's go through. The order that we had said that we wanted to use was vertical stretch or shrink, and then horizontal, and then reflection, and then vertical. You can do your vertical stretch or shrink at any time. It doesn't have to be it doesn't have to be at the beginning. It's just easier to see that stretch or shrink when you're trying to do several things at one time if you do it at the beginning. All right, so if we start with our vertical shrink, then remember that your vertical stretch or shrink is just going to be the number that is out in front of your function. It might be easier to see if you take this 2 and subtract it over to the other side, because when you subtract it over to the other side, then you can see that's a vertical shift. So then it makes it a little easier to, there's less over here on this side. So that negative, that 1/2 out in front of the function is going to be my vertical shrink. So it's going to make it go half as high as usual. If that was a 2, it'd go twice as high as usual. If it was a 3, it'd go 3 times as high as usual. So I'm going to take my original function, which is right here, and then I'm going to shrink it so it only goes half as high as it normally would. Okay, so there's my first step. I numbered that number 1 right there. All right, then the second thing I want to look for a horizontal shift. So any value subtracted from x is a horizontal shift. So that's a horizontal shift of +3. So we're going to take that pink graph that we just had right here, and we're going to go over 1, 2, 3 and draw the exact same thing. All right, then we're going to look for reflection. And remember, if you have a negative out in front of the entire function, that's reflection in the x-axis. So I'm going to take that yellow graph, which was the last one I just had, and I'm going to reflect it in the x-axis. So that's my number 3 right there. And then last, I'm going to look for a vertical shift. And again, any value subtracted from y is a vertical shift. So that'll be a vertical shift of 2. So I'm going to take that orange graph and I'm going to move it up 2 and set it back down. And that's going to be my final graph. All right, then for number 28, they asked us with an absolute value to find f of 0 and to find where f of x is equal to 0. All right, so f of 0 literally means put 0 in for that x right there. So I'm going to come over here and put 0 in for that x right there. So that would just be 2 times 0 minus 5, so -5 inside the absolute value. Absolute value of -5 is +5, and then we could do our 5 minus 3 to get our 2. Now, the other one, they said, let f of x be equal to 0. Remember, f of x is y. So what they're saying here is let y equal to 0, set your function equal to 0. So this was my function right here. I'm putting 0 in for this whole thing. So that's going to be 0 is equal to the absolute value minus 3. So 0 is equal to the absolute value minus 3. All right, so we always have to get our absolute value alone on one side by itself. So add that 3 to both sides. And now once you have your absolute value, remember to solve it. You take what's inside the absolute value and set it equal to a positive and a negative of what's on the other side. So we're going to get 2x minus 5 equals +3 and 2x minus 5 equals -3. So add 5 to both sides, and that would give us 8, and divide by 2, that would give us 4. And then over here, add 5 to both sides, that would be 2, divide both sides by 2, and that would be 1. And remember, you can always plug these back in for x and check them to see that you do get 0, and you do in both of those cases.